Okay. If a function has an inverse, then it works like this. If I could say f of 1 equals 2, I'm just making this up, right? Then f to the minus 1, when you put this little superscript there, that's how you designate an inverse function, right? This thing right here means inverse of f. So if it is the inverse, then it should be that f to the minus 1 of 2 equals 1. So f of 1 equals 2, f to the minus 1 of 2 equals 1. An inverse takes you right back to where you started from. Right. If f of x equals y, then f to the minus 1 of y equals x. Right. We need this kind of thing because up till now, every kind of function that we had to solve in one way or other, we could solve by doing operations to both sides to isolate the variable, and the answer would be on the other side. Sometimes we had to factor, true, but in every case, we were able to solve for x that way. But there's a lot of functions that you can't do that with. For example, trigonometry, sine of x, cosine of x, tangent of x. You can't solve for the x when it's inside the function by dividing by sine, right? Sine is the name of a function. You can't divide by the letters, S-I-N. Instead, we need an inverse function, something that will allow us to remove the sign. So that's where inverses come up. We need them for the trig functions. We need them for logarithms, which comes up in the beginning of chapter 8. So that's why we need this concept of inverse functions. The kind of functions that you cannot solve, by doing operations to both sides, those are called transcendental functions.